the thing that I want to talk about today mostly is strings. Um, so what are strings? Well, they're just sequences of characters. Uh, just about every program that has a user interface, and even most programs that don't, have to deal with strings. The way we almost always communicate information from a computer to a user is through text, and anytime you're working with text, there's strings involved. And even if the computer is fancy and is able to communicate through voice, probably underlying that voice is it's actually just reading some text. So strings are everywhere. Let's look at a couple of examples. Well, let's make our directory for today. Okay, so anybody know how you define a string in Python? Yeah.
A variable and then just string.
Okay, so you define you can assign a string to a variable like you can assign a number to a variable. So we'll make a variable, let's call it s, and we'll assign it a string. And what does a string look like? Yep.
A multi-character combination.
So something like this?
Yeah, with quotations possible.
Okay. So this is something someone asked. How come when I try and return a string like this, it's not working? That's because Python thinks what you're doing here is not defining a string, but you're saying s is equal to a variable called this, and then there's another variable called is, and another variable called and another variable called string. So strings have to be delimited by quotations. Okay, so this is a string. If we look at s, there it is. This is a string. Any other ways to define strings? Yep.
Single quote.
You can use single quotes. Like so. This is another string. Why two ways? Yep.
Can you put the terminal up so we can see it back?
Sure. So why are there two ways? Yep.
So that way if you have like an apostrophe within like the string, it's not going to eliminate it.
Yep. So that's one handy feature of this. So for example, let's say something like this. This is Pat's string. So this apostrophe in there between after Pat is something that is used to delimit strings if you're using the single version. So that would cause an issue if you tried to do that with the single version. So for example, this works. And if we look at it, it's the string that we expect it to be. But if we tried to do this with single quotes, well, again, we run into a similar problem. There's an error there because we're assigning this is Pat, that's the end of the string, and then there's some garbage after it that the Python interpreter doesn't like. So double quotes are useful when you want to use a single quote or more of them inside your string. Single quotes are useful, let's say, when you want to use double quotes inside your string. So that's helpful that way. Does this solve all the problems with quotes? No. What's the problem that we don't know how to solve? Yep. Yeah. So what if we want to do something like well, let's say something like that. So here we have this string, and we want it to include double quotes around runaway, and we want to use the apostrophe here to denote possession. And looks like we're going to run into problems no matter what we do. If we try and use single quotes, we're going to run into a problem because it seems to end it right there at the apostrophe. And if we use double quotes, we run into a problem even sooner. Because already the string ends right there. Those two quotes already define the string. Anybody know how we solve this? Yeah. Let's say you. Yeah. So something that this kind of problem comes up all the time when you are trying to write strings somehow in the same alphabet that the strings can be written in. And so we need a trick to deal with many of these types of problems. And that trick is escape characters. So the only problem with this string here is this second apostrophe here. If we remove it, it's fine. So that string works fine, but we want that apostrophe. And the way you get that in any string is simply to place a backslash in front of it. So this backslash says, okay, this apostrophe that's coming up, it doesn't denote the end of the string, it denotes an actual apostrophe. So if we look at this now, we see that this worked for us. And when the string gets displayed like this as a variable, when we display the value of this variable s5, you see that this was escaped. So there's no confusion about anything strange happening here. So there's this mechanism of escapes with a backslash that let you enter, let you use quotes as you like inside of a string. And this mechanism is really useful because it lets you do all kinds of other things, like include characters in strings that you don't normally have a way of printing, or that would otherwise break something inside of the interpreter. Anybody give an example of such a character? Yeah. Oh, that's the toughest one. So what if I want to have a backslash inside of a string? Yeah. You just use two backslashes. Let's look at that. So there it shows. So that two backslashes represents one backslash inside the string. It's showing you the escape code. And if I didn't do that, if I just did one backslash, well, it shows it again as two backslashes. Okay. Anything else we'd like to represent? Yep. Colon is no problem. We can represent that in just as a bare thing inside a string. There's no problem with colons. The real only danger is, so it's a simple printing character and it's stuck inside a string. So Python won't confuse it with anything because it's inside the string. Any other ones? Yeah. Percent? Yeah. Percent, we'll get to that shortly because nobody knows, or some people don't know why percent is special right now. Yeah. Octothorpe, again, is not a problem to do it bare because it's inside a string, so Python won't, when it runs across the octothorpe, it's still looking for the end of the string, so it's not going to confuse that for a comment. Yep. Yeah, so there's some characters that are hard to type, or typing them kind of messes things up. One of those is a tab. So let's say I want to start my string with a tab. So I could do that by pressing the tab key. It's kind of awkward. If there's a lot of them, I'll sort of run into trouble. Notice that it doesn't actually, when you display the string, it doesn't put the spaces for the tab, but it shows you the escape code for the tab. So you can enter a tab that way. And the really problematic one is the new line, because, well, let's simplify this. This is getting to be too complicated. Oh, sorry. Okay, so what I wanted to do is make a string with 2 lines, but when I got to the end of the first line and pressed enter, it got mad at me and said, well, you started a string here and you didn't finish it. Because the new line character is, important in Python. It tells you that this is the end of a command or the end of a line, and it doesn't like you to have that in the string. So if you want that, you use the new line escape. So this shows you that there's a new line in the middle of the string. All right, so this doesn't seem very helpful if all it's going to do is put a \n when you do this. So all these escapes here, when you inspect the variables that are these strings in Python, they'll show them to you this way. But many of you have discovered, and we just talked about it when discussing the assignment, you can print strings. And that's where these escapes show up the way they should. So that \n actually turns into a line between the 2 strings. So when I print that string, the \n moves on to a new line. When I go back and do this string with the tab, so notice the difference there. Printing it converts that tab into the 8 characters that show up when you do a tab. And it also converts the escaped colon here, the slash, or not colon, apostrophe, the slash apostrophe, it shows that as a regular apostrophe. So it's really when you print these things that all of these escape sequences get turned back into what they should be. Yep. No reason. Somebody asked about whether you could include a hash in a string. But the answer is yes, you can, and there's no issue. It's not doing anything in that string. Okay, so that's clear. Any other ways to define strings? Yep. As a character array, but we don't know about arrays yet, so we'll get to that a little bit later, next class, in fact. Yep.
Does argv count?
Kind of. So argv gives you a bunch of strings. Any other? So here we've been talking about what are called string literals, when you actually specify the string and write it out. So we saw single quotes, we saw double quotes. Any other way? Yeah.
If you give it a variable equals just 2 double quotes, just an empty string.
Yeah, so that works too. So for example, let's say x is equal to 2 double quotes. What's x? It's that string of length 0. Print x. That's not terribly exciting. It doesn't print anything. Yeah. Triple quotes. What's special about triple quotes? Yep. What do you mean by that? Okay, so triple quotes are for multi-line strings, so strings that go across new lines. And so they're a way to, when you have like a lot of text with new lines in it that you would like to assign to a string, they're a handy way to do that. So that string where we had a line in the middle, a new line in the middle, this one, we could have done that with triple quotes. That would look like this. One. Notice the prompt changed when I hit enter. There's still this ... It's telling me that, okay, I'm still expecting you to finish this thing you started here. and then you close it up with triple quotes again. That's S6. It has 1, 2, 3 new lines in it. If we print it, they show up the way you expect. Yeah.
Isn't that an alternate way to put quotation marks inside a string?
Let's see. Um, Yep. So there's another way to put quotes inside a string.
Is there a difference between triple double quotes and triple single quotes?
I don't think that there is, but well, so one thing that it should allow you then to do is something like this, which you couldn't do this way, right? Because that would finish the string. The second set of triple quotes would finish the string. So as far as I understand, there's two ways. You can use single quotes or double quotes, 3 at a time, and you get the same benefits that you get to use the other version inside. But it's not terribly often that you need a triple double quote inside of a string or a triple apostrophe inside of a string. Okay, so 3 kinds of strings: single quotes, double quotes, and in fact it's 4 kinds because it's 2 kinds of triple quotes that allow you to do multi-line strings. All right, so we've seen this print command, which allows you to print a string. So we can print S, print S1. There is no S1, S2, S3, and so on. This print command is a little bit more useful than that. It allows you to print just about anything. So it allows you to print numbers as well, not just strings. And it also allows you to print tuples. So remember, tuples are something we talked briefly about the first class. What's this tuple? So really what we're printing there is this pair, these 2 things, the string, the value of pi is, and then the number 3.1415. So you can print any number of things this way. Oh, not G. You can print any number of these things this way. So whenever you're asked to print something, that's what you should do. So that covers sort of the output side, how you get things to appear to the user. How do you read things from the user? Yep.
Input.
Yep. Is there any other way? Input. Yeah. So input is what some of you say. Anybody used input before? Yeah. Don't use it. Yep. There's a few other ways, but I want you to know the difference between input and raw input. Don't ever use input. It's almost never what you want to do. Yeah.
Has the get command in this, or is that?
There's a bunch of them. You can use get on standard in or a bunch of these types of things. But the one that we're going to stick with almost exclusively for at least for terminal stuff in this course is raw input. And raw input takes an argument. Do you know what that argument is? Yep.
String.
Yep. And what is that string for? Yes?
It prompts the user.
Okay. So this prints a little message saying whatever its argument was, and it sits and waits for the user to input something. So, and the return value from raw input is the string that was entered by the user. Now, again, this is good as a sort of basic building block for building things with, but it has its limits as well. For example, if the user wanted to enter more than one line of text, there's no way for them to do that. They as soon as they hit enter, that's it. Whatever they typed gets returned. So raw input is the thing we're going to use when we want to read strings from a user. Let's try again. So here's something we might have in, I don't know, a calculator program or something where we ask the user for a number. So we ask the user for a number. The user types 456. Now, and there's the user's input, x. Is that what we think it is? Yep. Yeah, so it's a string that has the characters 4, 5, 6. So if we try and do something like, say, 20 plus x, we get an error because we're trying to add the string 4, 5, 6 to the number 20, which is not something we can do.
Can't you do that anyways, but it will give the ASCII value?
Can't you do what?
Oh, wait. Can't you just add a... Oh, well, can you only do that with chars, adding them together anyways, but giving an ASCII value?
Well, so something you can do. So it makes sense to add things that are strings sometimes. And in fact, we can see that. Let's print S and S2. And something that I can do is actually add S and S2. You know what that gives me? What's that? The two strings together. So the concatenation of the two strings. So it builds you a new string, which is one string immediately followed by the other. Is there anything that is different about this kind of addition that makes it very different from what happens when you add two numbers together? Yep.
When you're adding two numbers together, it's like an actual value versus a string of just two things putting it together. They're actually combining the two versus just two separate things.
Yes, so it's something different is happening. But for example, if I take two numbers, 4 and 5, and add them together, I get 9. If I take 5 and 4 and add them together, what do I get? 9. So the order doesn't matter. What happens when I take two strings and add them together? The order matters. Right? It specifies I'm going to concatenate these two strings, one after the other, the first one first and the second one second. So if you change the order, they'll come out in a different order. So that kind of adding strings together, you can sort of pretend it's like adding numbers together, but it has quite different properties. Here's one. Let's say one more example of so there's a string with it's something you can do some effects with. There is a string with some escape sequences in it. That's \r. Anybody know what that does? No. Yep.
Is it like the beginning of the line carriage return?
Yeah. So it's called a carriage return, and it's a carryover from the days when computers didn't really even have displays. All they could do was print on pieces of paper. So they had this head that moved across the paper, printing characters on it, and different things you could do. If you did a new line, that would roll the paper up so that the head was on the next line. But if you did a carriage return, that just brought the head back to the beginning of the line. So, does anybody know what happens when I print this? Yep.
4 will be at the beginning.
Yep. All you see is 4. So it printed the number 1, but then moved back to the beginning of the line, and then printed the number 2, moved back to the beginning of the line, printed the number 3, moved back to the beginning of the line, and then printed the number 4. And how about if I do this? What's that going to print? Yep.
42.
Yeah. So it printed 12, moved back to the beginning of the line, did a 2, moved back to the beginning of the line, did a 3, and then moved back to the beginning of the line and did a 4. So nothing ever overwrote that first 2 from the 12. Okay. So that's actually something you can use sometimes to generate some effects. So things like counters and stuff, you can use these carriage returns to get those to work. So one thing I'd really want you to notice is the difference between the string, so what is actually in the string, and what gets printed when you print the string. So when you print it, all of those escape things get turned into what they're supposed to be, and the string gets printed that way. But when you look at the string, you get to see everything there. But back to this problem we were working on, where we wanted to enter a number. So we wanted to read a number from the user, but the problem we had is we're not getting a number, we're getting a string. So how do we get a number? Yep. Yeah. So let's do it slowly. So here we have this x, which is the string 554. Well, we can actually convert x to an int if we want, using this conversion method. We've seen it already. We saw that you could convert floats to ints this way. Well, you can convert strings to ints this way. We can also convert x to a float if that's the thing we're looking for. And if you want to do this in one line, you might do something like this. Right, so we have these two functions, raw input and this function float. And so first thing we do is we use raw input to read a string, and the result of that becomes the argument to float, which converts the string to a float. Okay. Anybody see any difficulties we might run into with that? Yeah.
If the user inputs actual letters and characters instead of just numbers.
Yeah. So if the user is not reading and decides to enter his name instead, well, we get a crash in our program. So in general, for the first assignment, and I think maybe not for the second assignment, at least for the first assignment, don't worry about this. Assume that the user is going to do the right thing, and they're not going to enter things that are not numbers when they should be entering numbers. We'll see very shortly the way to treat that. And the way you treat it is with some extra work, basically checking that what the user entered is something that should be there, so that you don't have these errors. Instead, you print a message to the user and ask him to try again, or tell the user that they made a mistake, but not crashing your program like this. And the other thing to be careful of is decide whether you want an int or a float. because if you try and convert to an int, but what the user entered is something that could only convert really to a float, you'll also get that crash. Okay. So that would have been fine if I was doing a conversion to a float, but ints shouldn't have decimal points in them. So you can convert strings to floats or ints as long as they're formatted properly. If you try and do that conversion and they're not formatted properly, you'll definitely get a crash. Okay. All right, so let's try and make something really simple with this. So let's do something which is like the dumbest form of cash register possible, where it's a cash register where someone can come along and they can buy one item that has a price, and they can give you some money, some amount of money, and the cash register tells you how much change to give them. So, so that's the program we want. It asks you for a price, and then it asks you for an amount of money, and then it tells you how much change to tender. So, how do we write a program like that? Where do we start? Yep. So we want to read an input. And what input do we want to read? Yeah. So first thing we want to do is read the price. And what do we do that with? Raw input.
What do you want to convert it to, assuming go to the next step?
So notice one thing. So this won't quite do it because this will read a string. We actually want a price. So what's a price? Is that an int or a float? Yeah, probably a float, right? The way we normally talk about prices are dollars and cents with a decimal place in between, separating the dollars from the cents. And lucky for us, $1 is 100 cents, so it works perfectly. Some other currency systems don't work that nicely, but Canadian and U.S. dollars and cents do. So we'll take that price and we'll convert it to a float. Okay. What next? Yep.
Which way do you prefer? Like, is it better to turn it into a float right away, or is it better to take the raw input that turns it into a float?
It doesn't matter. I mean, you're essentially doing the same thing. So whether you do it in 2 lines or 1, exactly the same operations are being executed. Once you get used to reading code for a while, then this becomes preferable because the whole idea is expressed on 1 line. What it is that you're doing is expressed on 1 line. It's a little bit easier to understand what's happening here, whereas if you split it across 2 or 3 lines, it could be harder to parse.
Even for style, like if you have like an opening a file, writing a file all in 1 line, what other doesn't matter? You wouldn't care? It's just like
So you can do a lot of things, many operations on one line. So here's, for example, one. When we look at files, you'll see that you can open one, read one, and even split it into its different lines or different words, all in one command. I don't care so much about whether you do it on 1 line or you split it across 3, unless it's getting really convoluted. But there is one thing that I care about, and one thing that everybody who programs for a living cares about. So you'll notice on my text editor here, or maybe it's difficult to see on the projector, there's a very thin line drawn here. I don't know if you guys can see that. Okay, but anyway, there's a line drawn right there, and that line is drawn at, if you look at the bottom display, it's showing you which column I'm in. It's drawn at 80 characters wide. So if I reach that line, I've got more than 80 characters. Writing code that has more than 80 characters on a line is almost universally viewed as a very bad thing. There's many reasons for it, but one reason, for example, is just the practicality of it. Here I'm using fonts that are a little enlarged, and I don't really have much room for more than 80 characters. So if you started writing code that was longer than that, I would end up having to scroll around, or the code would wrap around 2 lines, really confusing me. So 80 characters is sort of the default that people assume you have available. Another good reason for that is, well, so if you're visually impaired, you may have to use large fonts, and that may be all that you get is 80 characters. But if you're really visually impaired, as in you can't see at all, then you may be reading things through a Braille reader attached to your computer. And those Braille readers are typically not very long. They'll only be 80 lines long as well. Yep.
In regards to the 80 characters per line policy, does that include tabs and whatnot?
Yeah, so that includes the characters that are included in a tab. If your code is getting deeper than that, then you should find a way to refactor it or rewrite it so that it's not wider than that. Yeah.
What about when you have indented documents?
So if your level of indentation is getting so deep that you're pushing past 80 characters, then again it's time to rethink what you're doing and maybe factor that out into different functions. Right. So so for those of you who do this stuff, who know a bit more about programming, you can have blocks inside of blocks inside of blocks inside of blocks. Well, just take some of those internal blocks and turn them into functions themselves. Then they'll be they won't be indented so deep. Okay, so that's basically my rule. I don't want to see code that's wider than 80 characters. Up to 80 is okay. So let's say 79 characters is all right, but don't go wider than that. I mean, you can do a lot in 79 characters, right? Here we have the prompt. We're calling raw input. We're converting it to a float, and we're assigning it to a variable. And we're only halfway there. We're only at column 44. So you can get a lot done in 80 characters. Another style thing to look out for is, well, Python we use tabs to keep track of blocks of code. So a good policy is to set your tab stops to 4 instead of the default 8. That also helps keep things down. So it's not quite so bad. Each tab doesn't eat 10%, it only eats 5% of your available space. All right, so back to this calculator we're developing. What's the next thing we need to do? We've read the price. Yep.
Read how much the cash is given.
Yep. So that'll go the same way. Let's say and let's try and be consistent. Now what? So we've read the input from the user. How do we finish this program? Yeah. So what do we use for that? Yep. So the formula we want is cash minus price. And what is the what do we do with that? Yep. So we can do that.
Doesn't bother how much it's
Yeah, we don't even have to do that. So we could just instead just print it. Remember, print can print anything, including numbers, and cash minus price, if everything worked well, should be a number. So there we've written a simple program. Let's test it. So let's say that the price is $5.99 and I was given $10 or just 10. So it says 401. Is that right? Good enough. Seems to be. We might want to gussy this up a little bit. and say, well, at least what it is that we're printing out here. Yep.
Can you one-line it so that you have two raw inputs on the same line?
So you want to try and write this in one line? Yes.
I'm just curious, does raw input work like that, or does it have to be?
No, there's no problem. In fact, here's an exercise for you. Write this program in one line. It's not a difficult exercise. And I think you'll even be able to do it by under the 80 character limit. Okay. All right, so so there it's a little bit nicer looking. $5.99, $10, changes 401. Okay. A real simple simple program. A dumb cash register. All right, so we've seen how to convert strings. We've seen how to take one string and append it to another one so that you get the concatenation. That's using the plus operation. Anything else you would like to do or know about a string?
Character arrays.
Yeah, character arrays. Any, yeah. Yeah, that's a pretty sophisticated problem. So if I give you a word and ask you to use it in a sentence, that's something you could try and write a program for. Not easy. Yeah.
Earlier on, you assigned a tuple to a variable and had a number and a string. What is that variable considered then by Python? String?
It's considered a tuple. So it's a tuple whose first element was a number and whose second element was a string, or vice versa. I don't remember. What's that?
When you're analyzing it later, when you're going to do that in Python, look at it separate variables within one.
Yes. So actually, next class we'll talk about arrays and tuples and how you can look at the different parts of the tuple individually. Yeah. Yep. Yes. Percent sign we'll want to look at. What's a really basic piece of information about a string that you might like to know, though? Yeah, the length. So might like to know the length of a string. Just do that. So len, this is an important one because it tells you the length of a string, but it'll actually tell you the length and number of elements in a lot of other things in Python. So it's a good one to remember. For strings, it tells you the length, that is the number of characters that are in that string. Yep.
And does it start at 0 or 1?
Well, the length starts at 0. So for example, if s is the empty string, and I ask for the length of s, there's no characters in that string. So it starts at 0. So this is a string with 21 characters. We figured that out already. What about this string? What's the length of that string? Well, I added something to it, right? I put this \n here. What's the length of that? 20. So what are the possible answers? 21 didn't change. 22, we added a character, or 23, looks like we added two characters, right? A \, and an n. So who thinks it's 21? Not too many. Who thinks it's 22? And who thinks it's 23? Yeah. Well, let's find out. It's 22. So this \n is just a shorthand for the one character, which is the new line character. It's just really hard to print, but it's just one character. So it's a particular ASCII code for that represents a new line. So those escapes that we put in, they don't count for two things. You don't count the \. You just count the one character that you're escaping. Yep.
Is there a way to dictate between like types of length, bytes versus whatever?
For strings in Python, it's not counting the number of bytes used. It's just counting the number of characters. So
Like, is there an option like comma, whatever, a flag?
I don't know. I don't think so.
So they just count.
Yeah, I'm not positive, but I don't think there's any other way to get this to work. But this is sort of the behavior you almost always want, because if this were, for example, a Unicode string, it would actually be using twice as many bytes, but you really are interested in the number of characters, not the number of bytes that it's using. Okay. All right. Yep.
Like, can you like find letters within strings, or how would we do that?
So we'll see a bunch of the string things you can do shortly. A bunch of the methods, including finding things inside of strings, changing things inside of strings. But before that, I would like to take a quick look at something you'll need for the assignment, which is printf formatting of strings. Okay. Anybody know what this does? Yep.
It will insert the integer at the end into the string.
Yes. So, I typed in this string, and in the middle of the string there was this %d thing appearing, and then after the string I put a percent and then a number, and remarkably, actually what happened is that the string that I got had that number inserted into the string. So this is called printf formatting. It comes from the C or even earlier programming languages. So it's more than 40 years old, but it's an extremely handy way of doing things. So there are all these special character combinations. For example, %d, %f for floats. And the way you use these things is, while you insert these special codes inside of your string, you follow this string with a %, and then you define a tuple which has all of the values you should substitute in the order they appear in the string. So this %d, I want that to be substituted with a 10. The %f, I want that to be substituted with 3.1415. And if I look at the string I get, that's indeed what happens. Yep.
So
%d is for integers. The D actually stands for decimal. It means it's an integer displayed in the way we usually write integers in decimal notation, base 10. And %f is for floating point numbers. Yep.
Can this be used for conversion to print as a different one, like to print a decimal as a float, or print decimal as hexadecimal?
Well, let's see what happens. So let's say I take this string, and I have a well, let's try and reverse things and see what happens. So I'm going to take that integer 10, I'll try and print it as a float, and I'll take that float and try and print it as an integer. And indeed, it does what you expect. It takes 10 and prints it out with all these decimal places in it, and the float, which was 3.1415, just gets truncated to an integer. Yep.
So if you wanted to put in two floats, would you just put in %f in both places and then have two floats at the end?
Yep. So just like that. Usually anywhere you can put in a float, an integer works too. So there's no problem that way. Sometimes it doesn't go the other way. Yes?
Will this work fine with triple quotes?
Good question. Yep, seems to be fine. And that will even let you, that's, So no problem using that with triple quotes. Just put the percent and then the tuple that you need to substitute on the same line as the closing triple quote. Yep.
Would that work though if the tuple was predefined as like a string
Would that work if the tuple was predefined as a string?
in conversion to a different?
Well, so what do you mean?
Like as in if like because what you're doing is you're just putting I guess numbers, but if you had like a string of like 314.6.
Okay. So let's see what happens. Let's say we want to format something as an integer, but actually what we give is a string.
Well, like,
Oh, sorry. It's not a comma that I want, it's a percent.
but I mean, if there's like an actual number though, like, because obviously string won't work, but
Okay, so it gets mad at you if you put a string there, and it gives you a fairly informative error. It says the format was %d, and I need a number. Its number is required, not a string, because you gave it a string. So let's see what happens if we... Still not happy with that. So you really have to give it a number to make that work.
so really it's not using the float function or
No. No. That will work because you've converted that string to an integer before using it. Okay, so a couple of these things are %d, %f. There's many other ones. %r is a useful one. We can even look at %g. So, and %s. So %d is an integer, like that. %f is a float. %r, anybody know what that is? Yep.
raw data.
Yeah, raw data. It doesn't matter what it is, it's just going to print it. So you can put a string there, or I can put anything that I want there. So let's do 2 of those. Anybody know %g? I'm not convinced. I'm not sure that this even works in Python, but
It's a
yeah.
many.
And %s? Strings. That's one that makes sense.
So what is %g?
Well, let's see. So %g is another way of doing floats, and the %f and %g differ in the way they will handle really big or really small numbers. So I believe %f will try and show you a decimal expansion, whereas %g will do scientific notation if the number gets big enough.
What about small as well?
Yeah, if the number gets small enough as well. So if it's a number very close to 0. Okay, and now finally, this gets even more exciting. You can modify these things. Anybody know what this does? Let's just start printing them directly. What's that? No, not really. Yep.
Print 2000.
Well, let's see. It does that. Anybody know what it just did? Yep.
Does it limit the decimals, or well, not saying this has decimals, but does it reserve a certain number of space for whatever it is to be printed?
That's right. So the D is still the clue that this is an integer that it's going to print. The 20 following the % is basically the precision or the number of spaces to use. So it actually pads out the thing until it fills up 20 spaces. Yep.
Can you replace the padding with an asterisk or something else?
I don't think so. I think it'll just do spaces.
So just do like print asterisk.
Yeah, you think you'd have to do that by hand.
Yeah.
Yeah. All right, so there's another, things get more sophisticated still. And let's say, anybody know what this will do? Yep.
It'll leave 8 spaces, and then the precision of the decimal will be 4 decimal places.
Yeah. So it so it doesn't leave 8 spaces, it only leaves 1 space, but it prints it so that the thing occupies in total 8 spaces. That's what the 8 was for, and 4 of those spaces should be after the decimal place.
So what happens at the beginning if it's too big? Does it just truncate it?
It just overflows. So if it doesn't fit in the space that you asked it to put it in, it gets bigger. That's probably better to have ugly looking output than incorrect output. All right, so now we can actually, let's just use this and try and make this a little bit prettier. So let's say percentage. So we're going to print some cache values. So how should we format them? Yep.
Just one other question.
Yep.
You said %G tries to put it inside the notation.
Yes.
Would that mean it would try and round it to fit in the space provided too, or?
I don't know. You'd have to play with it. It's been a while since I used those. But you can play with them and see.
I think I did like 53 bytes.
So if we're going to print a cache value, if we're going to print a number that's supposed to represent money, how do we do it? How should we do it? How should we format it? Which letter? Yep. Floating point. And any kind of floating point? Yeah. So we want 2 decimals. And let's make this thing pretty. Let's get everything to try and get everything to line up. So we'll format it. We'll give it 10 digits to work with, and it'll go on the right of those things. Yeah.
Is there a double in Python, or is it just one?
Don't know. I think there's only 2 kinds of numbers in Python. If you want double, you have to do something special. We will. Yes, but not easily accessible. We may get to that near the end of the course. So all of those things are somewhere in Python, but not that you get to in the easy, obvious ways. All right, so we'll print the price. We will print the cache. And then we'll print the change, all nicely formatted. Yep.
Can you specify like where you want it to start on a line to print, besides using /t or backslash?
Not really. So you put in some spaces, or or have a string which is just a bunch of spaces and it's the right line, and print that beforehand. But there's nothing obvious in the print. All right, so price, cache minus price. Let's give that a whirl. $5.99, $10, and we got a error. Anybody see what the error is? Not an obvious one. Yeah.
It's an F. It should be an S.
No, both cache and price are.
Oh wait.
So this is actually a problem with with order of operations. So looks like it's difficult to understand. So now here's one way to easily fix it. Maybe I should look at my own screen. Okay. So this error that we got was actually a problem with order of operations on this line, that somehow this subtraction is not happening before this percent operator. So we saw that percent is, well, it's also used for modular arithmetic, which is the same level of precedence as division, which has higher precedence. So something was going wrong with that. Basically, it was applying it to just the first part. So there's one fix. We could have also used parentheses, but we'd have to be careful with that too. Yeah.
Can you do a float so you assign the number of decimals on the right side but leave the left side undefined?
Yes. Looks like this. So it'll just do the decimals, and it'll be whatever width it needs to be to include everything, and the 2 decimals. Yeah. Okay, so you can actually make some nicely formatted output this way. These kinds of routines come up all the time when you're trying to polish a product and make it look good for users. Okay, so good. We've seen string formatting with the Printf formatters, and I encourage you to go ahead and read about those if you want to do something fancy. There's more than just what we've seen here. You can specify, for example, for numbers, things like whether or not it should always print the sign. So sometimes, if it's a positive number, should it put a plus in front? If it's a negative number, should it put a negative, and so on. So go ahead and read all those, and there's more than just the ones we've seen here as well. But a few more things to look at with strings. Let's go back to interactive mode. So one thing you can do with strings is examine their characters individually. And so string is a sequence of characters. There's a first character, there's a second character, there's a third character, and so on. And you can access those using this. It's called the indexing operator. This gives you the first, so the characters are numbered starting at 0. That's why this string at 0 is T, at 1 is H, at 2 is I, and so on. So that's great. You can see the characters one at a time. There's actually, in Python, there's some very nice features. You can ask for a character range. I want the 5th character, or character at position 5, up to the character at position 10. Yep.
So could you use that as a definition, like as in to define a variable?
Sure. No problem. Yep.
So I know it's a bit ahead of the class right now, but does Python treat strings in the same way that C++ would treat them, as character arrays? Or
They're represented the same way, but you don't really see that. You don't generally deal with individual characters. So, but yes. Yeah. Okay, so you can take character ranges. Right. So we see what happened there. 5 to 10. This is the string at position 5, is this I, and then we go up to, so 5, 6, 7, 8, and 9. So up to, but not including position 10. Okay. You can leave something unspecified in these ranges. Anybody know what this will do? Yep.
beginning.
So this will do the first 10 characters, so everything up to but not including position 10. And you can leave the second part specified, in which case you get the suffix, so the thing starting at position 5 and going to the end of the string. And actually, ranges can have 3 parts. Let's say 0 to the length of s. So what will this give me? The whole thing. 0 right up to but not including the length gives me the whole thing. And then there's a third part. Anybody know what the third part that I can put to a range is? Anybody see what happened there?
Every other.
What's that?
Every other.
Yeah, so this says actually start at 0, give me that letter, and then skip 2 and give me the next letter, and then skip 2 and give me the next letter, and skip 2 and give me the next letter until you get to the end. So this is kind of redundant. If we just leave these blank, then they'll by default go from beginning to end. So that gives us the same thing. So that gives us every second character starting with the character at position 0. If we want every second character starting with position 1, there it is. And anybody tell me what this is going to do? Yep.
Resort to a default or not at all.
So one answer is default or nothing at all. Yep. Yep. So that reverses the string. So leaving these our first 2 arguments out just says, okay, do whatever makes sense for the other arguments. And -1 says, well, I want you to print a character starting somewhere, and then print the character before, or use the character, and then use the character that comes just before that, and then the character that comes just before that, and so on. And so the only way that makes sense is if you start at the end and work your way backwards. So there's a cute way to reverse a string in Python. Use a character range that has a negative index, and of course you can get every second character starting from the end and so on. Good. And something that hopefully the internet's working today. Strings are in Python what are called objects. So let's see what they can do. So typing Python something something almost always takes you to either a Stack Exchange answer or to the Python documentation. And so if we look at strings, we see that they actually support a whole bunch of things. There's a bunch of methods: capitalize, center. If you're trying to print things nicely, you can get them centered. You can count things inside of strings. You can decode them, and so on. So for example, we've got our string s. Let's count the number of i's in s. There's 4 of them. 1, 2, 3, 4. Let's count the number of occurrences of ai. There's only 1. It happens in fairly. Number of l's. There's 2 l's. 1 there and 1 there. What does this center thing do? Center takes 1 argument. It's an integer. And it reformats the string or produces another string which has padding, so that if you printed it in that many columns, 80 columns, it gets centered. So it adds space to the beginning of it to make that work. Does it add it just to the beginning or to the whole thing? It adds it actually to the entire thing. So it adds spaces both before and after. The really useful one, so count is a very good one. You can ask questions like ends with, Does this string end with G? Yes, it does end with G. Does it end with ing? Yes. Does it end with Q? No. So it gives you a true or false answer. You can search inside of strings. So what's 10 here? Yep.
The initial position of fairly
Yeah.
in the string.
So if we look at that string at position 10, it's an F. In fact, it's the beginning of the word fairly. So if we look at the string from 10 onwards, that's where fairly starts. So you can find the first occurrence of something that way, get the index of it. You can do all kinds of conversions. So you can convert lowercase, uppercase. You can even say, make it into a title. So convert the first letter of every word. And you can do replacements. So this file just defines two strings, which are limericks. Limerick 1, let's print it, and limerick 2, limerick 2. So let's take one of those limericks and change things. So we can replace Australia with, I don't know, Southeast Asia, maybe, and print the result. So this occurrence of Australia here gets replaced with Southeast Asia. And we could take, for example, limerick 1. And what would be something good to replace in there? Maybe we'll do mine with use. And let's keep going. Let's keep replacing things in the resulting string. We'll replace assign with abuse. Oops. We want to do that to the first limerick, not the second. Okay. So there's an overview of strings, and certainly everything you need to know to do the assignment, and a lot more. So we'll pick up again on Monday, starting to look at arrays. And in the meantime, I suggest you start working as soon as you can on the assignment. A good place to work is actually in the TA room when the TAs are there. That way you can get help instantly.